The Planck space fluid thermodynamic model. Dimensional analysis was used to define the Planck units for volume, mass, charge, entropy, temperature, energy density and pressure as given in the list below. The fundamental constants which define the Planck units are the Planck constant, the speed of light, Newton's gravitational constant, the Boltzmann constant and Coulomb's constant. The only difference between this study and others on the Planck units is that the Planck entropy is formally defined here as the Boltzmann constant. The Planck charge and the electron charge define the fine structure constant, alpha, as shown in the green text below. The above expressions for the Planck units can be solved to get the 5 fundamental constants as functions of the Planck units. The fundamental constants can be expressed solely in terms of the m, v, t, s, and q Planck quantum properties as follows. The Planck time can be described by these same Planck quantum properties as: the definitions of ppl and ρepl require that the Planck fluid equation of state parameter has a value of 1. The Planck fluid is quantized as cubes with Planck length sides. Cubic closepacking of the Planck quanta completely fills flat, 3-dimensional space. When the self-interaction of the Planck quanta at the square surfaces of a Planck quantum is modeled using classical gravitational and electrostatic forces, the strengths of these forces are found to be equal and at their maximum values. Note that this degeneracy of classical forces is a type of unification of forces. The normal matter Planck charge is defined as positive, which means that adjacent quanta will repel each other. However, these repulsive electrostatic forces are exactly balanced by the attraction forces of gravity on the adjacent quanta. It is this cancelling of the interaction forces that leads to a zero quantum interaction energy for the Planck fluid. Ideal gases of matter also are characterized by a zero quantum self-interaction energy. It follows from the above equality of forces constraint and the relation of the permittivity of space to Coulomb's constant, that the permittivity of pure space in the Planck fluid is the same as in the vacuum space fluid. This relation for the permittivity of space is strong evidence that the Planck fluid is a space fluid. The Planck fluid quantum and the first law of thermodynamics. In the limit of a single quantum, the internal energy from the first law is given by: for a non-self-interacting fluid, the chemical potential is equal to the rest mass energy of the quantum. Consequently, for the Planck space fluid we have the following thermodynamic relations. For the Planck space fluid, the values of the extrinsic properties of the fluid, m, v, s, are the product of the number of Planck quanta times the value of the corresponding quantum property. For the intrinsic properties of the Planck fluid, T, P, ρe, ρs, ρq, all of the quanta have the same value as the bulk fluid. Consequently, a single quantum obeys the same equation of state as the bulk fluid. Planck fluid constituents and antimatter. It is proposed that the Planck fluid quantum properties are derived from its constituent gravitons and grand unified bosons. The antimatter Planck quantum consists of antigravitons and antigrand unified bosons. The Planck charge in the antimatter Planck quantum is negative. A Planck fluid contains equal numbers of matter and antimatter Planck cubes. Consequently, the Planck fluid is an electrically neutral, polar fluid.